Okay, so last time we were talking about how to show that something is a solution to a differential equation. Let's see, there's the differential equation. Um, so what we're doing today, I guess that's the problem that we were looking at last time. What we're going to be doing today is an application of systems of equations. And you could use this as a kind of a template for lots of different things whenever two um, quantities are being mixed together. So those quantities could be populations as well as these tanks. So we're going to be using a couple of tanks. So tank A and tank B. Let's call this tank A, tank B, and let's say both tanks have 50 gallons to start with. Both 50 gallons. And let's say that they're both pure water to start with. Okay, so in tank A, I'm going to have some incoming brine, and that's going to be 2 ounces per gallon and 1 gallon per minute is incoming. And for tank B, I'll have some stuff coming in at 3 ounces per gallon and 2 gallons per minute. Okay, now to get a little bit more complicated here, we're going to have a pipe that connects A to B, and it's going to be pulling this mixture out at 1 gallon per minute. And well, let's just make a symmetric problem. How about this one's pulling in that way at 1 gallon per minute? But also we have some outputs. This one's flowing out at 1 gallon per minute. And this one, let's see what this one needs to be to make things work. Because I don't want the total amount of fluid to change in my system. Okay, so what is the total incoming amount for tank A? I've got 1 gallon a minute coming in this way, and 1 gallon a minute coming in this way. And then I've got, so that's 2 gallons coming into the tank, and then I've got 1 gallon there and 1 gallon there going out. So I've got 2 gallons per minute coming in and 2 gallons per minute going out. Good, so that's balanced. And then how about on this side for tank B? I've got 2 gallons per minute coming in from the up here, and I've got 1 gallon per minute coming from tank A. So altogether I've got 3 gallons per minute being pumped in, and then I've got 1 gallon per minute being pumped out so far. So that leaves 2 gallons per minute that I need to get rid of. That's the excess, right? So we'll go ahead then and make our excess here 2 gallons per minute. Okay, and that'll keep our fluid balanced. Good. All right, so now let's see if we can model our rate of change. So let A of t and B of t be the amount of salt in tanks A and B respectively. Okay, so now what are the units of dA over dt? Let's see, the units should be ounces per minute, right? And so let's see if we can go ahead and write our differential equation. Remember, we're looking for, I'll go ahead and put some parentheses here, rate in on the top here minus rate out. Okay, so my rate in looks like 2 ounces per gallon times 1 gallon per minute. So that the units then give me ounces per minute. That works. Okay, plus what else is incoming? I've got this gallon per minute coming in from tank B, And so that's going to be 1 gallon times, let's see, 50 gallons of fluid, and then B ounces of salt. Okay, and then I'm going to be subtracting the rate out, which is, let's see, I've got 1 gallon per minute going out here and 1 gallon per minute going out here. Now, does it matter in terms of my mixture where the fluid is going? It doesn't, right? So I can just go ahead and sum these two outputs together, and so I can just say that that's 2 gallons per minute going out, and then that's going to be times A ounces divided by 50 gallons, right? And so this will simplify to ounces per minute. Good. So that's my dA over dt. Can we write down dB over dt now? So for dP over dt, let's see if I can keep the picture here. It looks like 3 times 2 is coming in, plus, what else is incoming? I've got this is incoming from tank A, so therefore I've got, that's 1 gallon per minute times A ounces divided by 50. Oops, I'm going out of my thing here. Okay, there we go. Minus, and then what is the output? I've got 2 gallons going out here, 1 gallon going out here, so therefore it's going to be 3 times B over 50. Good. Alright, so just to simplify my notation here, A prime, let's go ahead and write it in matrix form. B prime equals, let's see, that's going to be minus 2 over 50, 1 over 50. Notice that I'm writing this in terms of my A and my B first, my A first and then B. So it's really important to do that. And then, let's see, for the next one's 1 over 50 minus 3 over 50. Good. Times AB equals, oops, not equals. I've got a constant here, 2, 6. Good. Okay, so that's the differential equation. Now, what I'd like to do to the differential equation is to find the equilibrium. Let's call it AE and BE. And secondly, I'm going to make a substitution so that x1 is equal to A minus AE and x2 is equal to B minus BE, and I'm going to see what happens when I do that. Okay, let's see, for the equilibrium solution, I've got minus 2 over 50 times A plus 1 over 50 times B plus 2 equals, whoops, 2 equals 0. Remember, we're setting the derivatives to 0. And the second equation, 1 over 50 times A minus 3 over 50 times B plus 6 equals 0. So if I bring the 2 and the 6 over and multiply everything by minus 50, what do I get? Let's see, I'll have 2A minus B equals 50 times 2 is 100. Good. And then in the second equation, I would have minus A plus 3B equals 6 times 50, which is 300. Good. And now it depends on your favorite technique for solving this system. If you want to use Kramer's rule, you can. Just for fun, let's go ahead and maybe write down what it would be for Kramer's rule. For Kramer's rule, we would have that A is equal to, can you write down our determinants here? 2 minus 1 minus 1, 3, and then the first column is 100, 300, minus 1, 3, and then B is equal to 2 minus 1, 100, 300, and then we would have our 2 minus 1 minus 1, 3. Okay, so if we compute those, I just happen to have them handy here. A is 120 and B is 140. And so if you check, do those seem reasonable? Does it seem reasonable that A goes to 120? Well, let's see, it's 2 ounces per gallon coming in, and I have 50 ounces, so that would be 100 ounces altogether, right? So why isn't the answer more reasonable to be 100? It's because we have incoming from this other tank, right? And this other tank has more concentration than that, so it should be greater than 100 for A. Similarly for B, it's coming in at 3 ounces per gallon, and I've got 50 gallons, so therefore it should be 150, right? But the incoming from tank A is not as much concentration as the tank B, and so we're going to dilute that a little bit. And so it does seem reasonable then that the ounces of salt in the tank A is a little bit more than 100, and for tank B it's a little bit less than 150. Very good. That's 11 minutes. Let me stop here and we'll finish our problem in the next video.